Okay, so for example 5, what we're doing is writing those general rules, just like we did for 4b. So you see this little like f with circle g. What this means is f of g of x. Okay, those are equivalent terms. So that means we're going to take g and plug it in everywhere that there's an x for f. So our g function is 2x minus 5, so it's going to replace in our f function just that x part. So I'm going to have the square root. I'm going to replace my x with 2x minus 5, and then I have plus 7. So the black part is our function f. The green part is our function g. And then from here, you simplify. So you get 2x minus 7 plus 5 is plus 2. Now, I'm going to do the same thing with this. So we're going to find f of g of x. So g of x is 4 minus x. And we're going to take that and plug it in everywhere we see that x. So I'm going to get 4 minus x squared plus 4 minus x plus 2. So the black parts are, again, like the pieces of our function f that are there. And the green parts are what we filled in with our g of x. So now, in order to simplify this, we actually have to do all of these operations. So we're going to square this. We get 16 minus 8x plus x squared plus 4 minus x plus 2. And then remember, guys, to combine your like terms. So we have 1x squared, negative 8x, and negative x give us negative. Oh, I wanted to do that in blue. Negative x, negative 8x gives us negative 9x. And then 16 plus 4 plus 2 is plus 22. And there is our final composite function that is f of g of x or f of g, like that. Either way, fog or f of g of x. So now example 6 gives us a real world situation where we kind of compare what we're going to do here. So this was actually one of those lovely little word problems where you actually have to read what you're doing. So it says, clothes you wear post discounts on social media. The store allows customers to use multiple discounts. They simply need to tell the cashier in which order they would like the discounts to be applied. On your next clothes to wear, or trip to clothes you wear, in which order should you ask for the discounts? So this discount we're going to call f of x. And it's going to be how much we spent minus $5. And then this is going to be a 10% off. So we're going to call that 0.9 of how much we spent. Because if we spend $100, we're going to pay $90 because we get 10% off. So we're paying 90%. So now what they're asking us to do is compare f of g of x to g of f of x. Okay, so this one is where we plug in the g function to f, and this one is where we plug in f to g. So I'm going to do f of g of x in green. So I'm going to replace my g function with my f. So I'm going to get 0.9 minus 0.9x minus 5. And that's if I do the 10% off first, and then the $5. If I do them in this order. Oh my gosh, this is if I take the $5 off first and then the 10%. And so if I do that, I'm going to plug this we're going to plug the this in like that. Now, if I do this, I'm going to get 0.9x minus 4.5. Now, if you look at these two equations, the f of g of x and the g of f of x, which one is giving you the bigger discount? Well, this part of the equations are the same. But then at the end, you're taking $5 off versus here at the end, you're only taking $4.50 off. So your better bet is to have them take the 10% off first and then the $5 off. And you guys say that math does not have real life applications. So I hope that helps and that this was a pretty painless lesson because it's less than 20 minutes long.